Here we are looking at 4.3 real zeros of polynomials, day 3. We need to find zeros, and the steps are to list all possible rational zeros, and then to use Descartes' Rule of Signs to find out how many positive and negative zeros we might have, and then start testing zeros, usually starting with lower positive whole numbers. Then keep a lookout for upper and lower bounds and or zeros. We discussed that in day 2. And when a zero is found, take the new polynomial and factor it if possible, or keep testing zeros. You may have to use a new list of possible rational zeros from the new polynomial. Sometimes the list would be the same and you don't have to worry about it. Okay, let's look at this example. All right, so we have p of x equals negative x cubed minus 2x squared plus 5x plus 6. And we want to start out by doing the factors of p, which is 6. So positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. And then the factors of q, even though it's negative 1, it's still just going to give us positive and negative 1. Since we have only one denominator, even though it's positive and negative 1, we have just our values of positive and negative 1, positive and negative 2, positive and negative 3, and positive and negative 6. So these right here are my list of possible rational zeros. So now we want to use Descartes' rule of signs. So if we look at the polynomial, p of x, so let me just write here, we're going to use Descartes' rule of signs. Okay, and for p of x, we have negative x cubed um, minus 2x squared plus 5x plus 6. So that's a negative, positive, and positive. So we have one sign change. So that means we have one positive 0. And if we do p of negative x, okay, that's going to give us negative. Remember, for p of negative x, we are plugging in negative x. So we get the opposite of negative x cubed minus 2 times negative x squared plus 5 times negative x plus 6. Now, anytime we have an odd exponent, it's going to stay negative, and then it is affected by the positive or negative on the outside. So here we have a negative, and then another negative to make it positive. Here, negative squared is going to make it positive, affected by the negative 2 out front. So that is going to be negative. This is negative x and positive 5 combined. We will make it negative. And then a 6 positive. There we have a positive. So we have a sign change from the first term to the second term, and then from the third term to the last term. So we have 2, and then remember to step that down by an even number of 2 until you get to 0. So we have 2 or 0, negative zeros. All right. So now, what that tells us, if I get a positive 0, I'm going to then be looking for negative zeros. Um, let's try 1. See if that works for me. I have -1, -2, 5, and 6. And I had my p of x right over here that I was looking at. So when I do my synthetic division, I bring down -1. 1 times -1 is -1. I add, going straight down, that's -3. 1 times -3 is -3. I'm going to add, I get 2. 1 times 2 is 2. I'm going to add, and I get 8. Okay, so this is not a lower bound, it is not an upper bound, and it's not a 0, so I'm just going to cross that out. So let's try 2. -1, -2, 5, and 6. When I bring this down, that's -1. 2 times -1 is -2. Add straight down, I get -4. 2 times -4 is -8. Add straight down, I get -3. 2 times -3 is -6. Add straight down, I get 0. So this is a 0. So I'm going to circle that because then I remember that that was a significant part of my work. And that tells me that I have a 0 of x equals 2. Okay? Now, my new polynomial from this synthetic division is -x squared minus 4x minus 3. Now, if I'm going to be, this is a quadratic, and I could set this equal to 0, and I can divide everything by -1, and I will get x squared, if I divide by -1 over there too. X squared plus 4x plus 3 still equals 0. And if I do my product sum rule, or I could use quad 3 on your calculator, that's a 3 and a 4. For my product is 3, and my sum is 4. So 3 plus 1 is 4. So I could do x plus 3 and x plus 1 and get a 0 of x equal -3. And over here, get an x equal -1. Now remember, I get those by setting each factor equal to 0. So if I did x plus 3 equals 0, I would have to subtract 3, and that's how I get x equal -3. Same thing with x plus 1 equals 0. I would subtract the 1 to get x equals -1. So anyway, my zeros are 2, -1, -3. And that is what you're doing for these problems for today.